All right, we are live, guys. Okay, so good afternoon for everyone that's coming in. We are doing our Tech Talk Wednesday. I've got with me right now Marc. Hey, Marc.
Hey, George. How's it going?
Good, good. Marc's the CTO for MCP Networks, and today we're just going to ask him a few questions about some things networking, and he's going to be replying to us. And if you guys have questions during the conversation, feel free to leave them in the comment section. And if you're catching this as a recording after the fact, go ahead and leave your questions down there anyway, and we will get back to you as soon as possible within that thread. So we're going to do this once a week, and it's an opportunity for us to engage with the community, share the knowledge that we've acquired through building out our products, and try to pay it forward and give back. So without further ado, Marc, let's start off with well, how do you want to start off today's session?
Sure. So I think let's start off with clarify. I think we're going to shoot for every other week, but I guess it depends on the popularity. If we get a lot of questions, then maybe every week will be appropriate. But I also want to provide valuable content. So basically, I'm a MikroTik trainer, IP routing switch guy, and I recognize that, hey, I've got a lot of history in this industry, lots of expertise, and I wanted to share some of that expertise out and be available as a resource for questions that I may know the answer to. No reason for somebody to be stressing over something that's maybe related to IP routing or MikroTik, and really it's an easy answer. So to start with, today what I wanted to cover was some AWS performance with the MikroTik cloud-hosted router, or CHR. What struck me when I first started playing with MikroTik in the cloud was that when you fire off an AWS instance, they are labeled as a network performance of 10 gig, 20 gig, 40 gig, high, medium, low, and very low, and moderate. That's the word they used. And I said, what do these things mean? I mean, I get 10 gig, but the rest of them, what do I want to use here? And obviously they've got different instance sizes that will cost you from anywhere from less than a penny per hour to multiple dollars per hour to run the server. And I said, well, what do you need to run a good router in the cloud? And we'll talk here for a moment also about why would you want to run a router in the cloud. But first I want to talk a little bit about the performance. So to start with, when you're firing up a AWS instance, you get to look at the different kinds of instance and the flavors of the instance that you could run, right? And so, you might get one core, different sizes of RAM, you might get multiple cores, faster CPUs, and so Amazon has these sizes of nano, micro, small, medium, large, extra large, double extra large, so on and so forth, to get these huge, huge instances. And what I wanted to just cover today, and we're going to write up a white paper and publish this knowledge so that anybody can see at a glance. What does that relate to in terms of speed on the network side, right? We see what the CPU speed is. We know how much all the stats of everything else memory-wise and stuff, but you don't know how many megabits per second can I get through this kind of instance. Unfortunately, while I was testing, my individual Amazon account broke, so I can't spin up new instances for the time being. I've got to take it open on that. But I'll share with you what I've learned so far. 10 gig instances with the MikroTik cloud router are not going to give you 10 gig of performance. Instead, it seems that every 10 gig instance that I tried capped out exactly at 600 megabits per second, maybe 599.9. And so it's odd to me that it gets that exact number on every 10 gig instance. So, we tried the R4, the i3, I think there was a C5 in there, C4 in there, and although they say they're capable of a 10 gig interface and they've got enhanced network performance, and I know some of that has to do with drivers and special tunings for Windows and Linux. When you're using a MikroTik CHR, you should expect to get 600 megs of performance out of that. That was a good place to start, and then I said, well, what if we can get better performance on a low or a moderate or a high? And I wonder if we can. And so the next step was, hey, let's try the smallest instance we can try. So we went to a T2 Nano. T2 is the mixed performance. So C's are optimized for compute, R's are optimized for database, M's are optimized for memory, G's are optimized for graphics, I's are optimized for storage. T's are the blended performance tier. And so I tried a Tier 2 Nano, which is the smallest instance you can get today. It says that it has low performance on the network. So what does that mean? What that means is somewhere between 400 and almost 500 megs. It seems like there's some burst available in the T's series. It's not available in the other ones that we tested with the 10 gig. So the 10 gig went right to 600 and basically sat right there pegged at 600 all day long. The T's will kind of burst up and down. So if you're doing a longer term test, it's going to sit at 400-ish, and a short test might burst up to like 500.
So Mark, let me ask you, how did you do the testing? Like exactly how did you determine what that speed was?
Yeah, so I meant to cover that too. Appreciate you asking me that. What we did was spin up one instance and then a neighboring instance right next to it of the same type. So we had a 10 gig instance and then another 10 gig instance right next to it. They're in the same region and the same availability zone. And if you're not an Amazon expert, we can talk about maybe answering some Amazon questions at a different time. But the key here is that they're on the same subnet within the Amazon virtual private cloud, and so they're able to directly talk to each other at 10 gig. And not able to see that performance.
Okay.
So then the next step was for each different type or family of instance, we spun up 2 exact mirrors of the instance and then speed tested between them and let it run for a period of time and just measured the results.
Okay.
So the next step was to move from a low performance to a moderate performance and find out what does moderate mean? Because I've always wondered since the first time I saw that label moderate, and it was like, all of us I think can understand low means don't expect very much, but what is, is moderate, a couple hundred meg, or is that gig, or what is it? So when we tested moderate, what we saw was actually over 1 gig. It measured at like 1020, 1010, 1,000 megs per second. So, you're able to get better than a gig on a moderate labeled instance in Amazon. And unfortunately, I never did get to test the high. That's when my testing broke, my account broke, and I wasn't able to continue testing. So that's what I've got for today. And we intend to continue doing this testing, write up a white paper, and publish this information online so that other people like me who wanted to know what does that network performance label mean, they're going to be able to get that info.
I'm glad you reattacked that, because I was going to bring it up as well. The fact that when you were doing your research, you couldn't find anything that was published that explained this, right? And that's why you ended up doing this testing in the first place. Because number one, we found that you were getting lower results than expected in testing for our product Aries. But then, when you went out there to find it, it just wasn't there. So that's great that we're going to actually publish that and add that to the community. So that's awesome. Looking forward to that.
Exactly, George. So the other portion of this is to just be available as a resource. I want to share some data, and then if anybody's on the live stream or the recorded stream and you want some answers on something that I might be able to answer for you, shoot it out, throw the question in, and we'll see what we get, and I'll do the best I can to cover that.
Awesome. And I'm scanning the chat logs or lines to see if anything comes up, and I will be sure to ask you those questions as they arise. So I do have another question for you. What are some of the lesser known features of MikroTik? I mean, you are a SME, a trained certified SME for MikroTik. It's not a well-known brand in the U.S. I would say compared to, I mean, in the WISP arena, it's very popular, obviously, but compared to Cisco, I think some of the corporations and larger entities expect to see that name. They don't expect to see MikroTik. But from my understanding of it, it appears to be a pretty strong platform, and the feature sets are pretty similar to what you get with a Cisco, but without the cost attached to it. So, what are some of the lesser known things that even people that are aware of MikroTiks may not be aware of?
Yeah, George. So like you mentioned, I talk to people every week that are in the know on network stuff. They're familiar with Cisco and maybe have certifications and all kinds of knowledge in the networking industry and never heard of MikroTik. I'm the first time I've heard of it, or maybe they've heard of it, but they've never seen one in person. So yeah, absolutely. There's definitely room for growth here in the U.S. And to answer the question, what are some of the lesser known features? I guess I would say that one of the common ones that we see again in the WISP market that has been, hey, I didn't know that, that's really cool, would be the power over Ethernet feature on commonly port 5. I'll grab, this is one of our lab models that we like to use for 100 meg internet, called the RB952 or HAP AC Lite. He's a dual band radio guy, and if you'll notice on port 5 here, it says PoE out, probably backwards.
No, it looks right for us.
One of the things that's maybe not so well known is that that's a passive PoE port, so if you power that router, you can, especially as a WISP, you could power your CPE or the radio with the router here, and so that can save you, a power source, a piece of equipment. Also allows for you to tell the customer to reboot the router, and it will also reboot the CPE radio, which can be useful at times. The other use case for that is, there are MikroTik models out there with PoE out on every port. I believe that series is the 750, and that might be useful in a place where you want to run Ethernet cables but don't want to run power, and you could wire up a whole building or apartment or a house and do that with just one wire and not worry about power, and the power savings is a nice feature of the MikroTik. Mm-hmm. That's on the hardware side. I guess on the software side, maybe one of the lesser known features is that it's really easy to collect historical data, and you can do that with the graphing function. And so under the menu tool graphs, you can graph CPU, you can graph bandwidth, and I think there's one other thing you can graph, but this will generate on router files, and so you can connect to the router and look at the graphs and review them. So we highly recommend, and all the routers that we deploy, we automatically turn on that tool graph feature. We have not to date used it. However, as long as you've enabled it and turned it on, those graphs are being built and logged to the file system. So at some later point, you can always just turn on the web service and log into that router and look at them, and they're there. If you don't turn them on, they're not turned on by default. So it is important that you manually go in there and tweak that setting if you figure you might ever want to have that data.
Awesome. Cool. Well, thanks for sharing that with us. I'm sure there's a lot of other stuff that you have in your mind, but we have to keep it limited for now. So maybe next time we can hit on a few other features of
absolutely
that may not be so popular. So real quick, I wanted to add that David Bush said thanks for taking the time to do this. So a little shout out there. Thank you for tuning in, David. Yep. So we talked a little bit about MikroTiks. Let's talk about the MikroTiks that we use and maybe why we use those particular models. You already mentioned the HAP AC Lite there for 100 meg. Can you give us a little bit of detail on how we came up with that, why we chose those, and so on?
Sure. Yeah. So first off, we selected the MikroTik platform overall just because it has a super robust feature set and it's completely exposed over the API, which makes it really easy to program for. So like you mentioned, George, you know, there's $100,000 Cisco routers out there with the same feature set, not the same performance, obviously, right? You've got Cisco able to do, you know, 100 gig and better at line rate with all features turned on, and you're not going to get that out of a $50 router, right? But at the same time, you know, this guy's able to build MPLS tunnels. You're able to do traffic engineering, BGP, OSPF, all kinds of super high speed, and not technically high speed, but like military term jargon, high speed, very, very awesome protocols that, you know, it's amazing to see that in a under $100 piece of equipment. But specifically, why did we pick the 952? We like this one because, again, it's got PoE, it's got PoE in, PoE out, it's got dual band radios, AC. Performance is great. They're a little workhorse, and for anything up to 100 meg, they work fantastic. And the price point, you know, we're talking under $50 for that model. So we love that one. If you're getting over 100 meg, that's where we come into a D52 or a 962. Though that's a half AC full, and I'm not sure if the D52 has a moniker. I think they call it the AC2 or AC squared.
AC2, yeah. Yeah, it's subscript up there, yeah.
Yeah. So both of those have a stronger radio, and so you'll get more performance and distance out of those units, but their price point goes up. But they both unlock gig, and the half AC full, the 962 adds an SFP port, which is pretty awesome if you're doing fiber or you need to cover some distance. You need to convert that media.
Now, I'd like to share something quickly about the 952. Because I used it in a gig environment. I have gig internet. Well, actually at the modem it's about 800 meg, right? But I was using the 952, you know, capped at 100 megabits for almost a year. And you mentioned workhorse, man, I tell you, I never had to do a reset. It never locked. It was never an issue that, hey, let me go reset the modem. And I've had, you know, other hardware, you know, some other routers that I've used that actually had more speed or more bandwidth. You know, they could go over 100 meg, but the performance wasn't as good. And even the rest of the family could notice it when it came to streaming or transferring files or anything. It just seemed slower. So for that thing being $50 and for it being, you know, capped at 100 meg and so small and lightweight and all of those things, it felt, and maybe I'm a little biased, I don't think so though. I mean, this was real world use and this was feedback I was getting from users on our home network. And we're a connected family. We don't even have cable, so it's all streamed. And it felt really quick. So it's a strong testament to that product. I do want to ask you, Mark, you mentioned earlier in the conversation about CHR and some of the cloud core stuff. Can you talk to why we use that and maybe follow up on what your comments were on that performance?
Yeah, so the cloud core is really the physical version of MikroTiks' high performance routing platform. So to start with, they've got a 9 port, and they go all the way up to a 72 port. 72 core. The 9 is the cores, not the ports. I had that little off. Anyway, they're really high performance, purpose-built routers. They're rack mount units that are built for, you know, sticking at a core or a you know, edge where you're really doing some aggregation and you need high throughput. Maybe you're doing some protocols there. Again, we talked about OSPF, BGP, maybe traffic engineering, MPLS. If you're doing that kind of stuff, the cloud cores are the device that you want. Even though I talked about, you know, this guy being able to do all that stuff, you would only want to do that in a lab. When you want to do that in production environment, the cloud cores are the ones to use. And so one of the things that you know, I talked about maybe using as a use case for AWS, and now that you mention it, it reminds me that you know, maybe I've got a physical infrastructure, I've got a data center here, and I've got a cloud core hosting that physically here as my router of choice for my data center, and I want to add some geo redundancy, and I want to put some of my data in the cloud and have an off-site backup storage location. And one of the things that's really cool that you can do is bind a tunnel between that cloud core router and put an AWS cloud-hosted router in that cloud, and that can be your edge interface between this cloud data center and your physical data center. And you can do full IPsec, very tightly encrypted, but also high performance tunnel between them. And that's why this performance matters, right? So if you're thinking that, hey, I'm going to get this big 10 gig instance and it's going to run my cloud hosted router and then connect to my data center, but hey, my backups take forever. Syncing data between my data centers here is really not the performance that I thought I was going to get. Well, that's kind of why I did that testing.
Okay, awesome. Before we get too far, I did want to bring up something here, that you are a MikroTik certified trainer, right?
That's true, yeah.
And are you going to be performing any training soon? A little birdie told me that you might be putting on some training courses. So what do you have on that?
Yeah. So we haven't got all the details scheduled yet, but I guess if you're in the, we're headquartered here in Fargo, North Dakota at the NDSU Tech Incubator, and been having some requests to do a MikroTik training session. And typically, I'm just training for, other friends and professional, I guess
peers, coworkers,
yeah, that are interested. And hey, can you do a custom class just for me? Mm-hmm. And typically that's how I run them. But with some interest being generated locally here for a course, I've decided that here in Fargo we're gonna throw a course together here in the next month or two. So there'll be details on that coming shortly. We just got to line up the venue and get it all worked out.
Is there a limit to how many people can sign up for the course?
Yeah, I do class sizes of no more than 10.
Okay, awesome. All right, so I do have a question here. It says, I don't really understand NAT rules. NAT being network address translation, is that right?
That's right.
That's right. All right, can you explain it for a novice?
Sure, I'll do my best. So for NAT, again, network address translation, first off, there has to be an understanding that all traffic goes across a network based on destination IPs, right? And so the first part of the packet is going to be some MAC address, source MAC, source IP, and a destination MAC and destination IP. And so what a NAT can do is translate some portion of that. And so a source NAT is going to take the source IP and it's going to change it and rewrite it within the packet. So why is that useful? Masquerade is probably the largest volume of use for this. And what a masquerade does is allow you to use one IP, like an internet IP, and masquerade that among dozens or hundreds or thousands of internal devices that all use that same public IP. So they're masquerade single public IP.
So for example, I have a modem from my provider that has a public IP, but then when it goes to my router, it's creating a whole new family of IPs for all the devices on my home network. And so when I go out to talk to someplace on the internet or to get data or ask for data or receive data, it's converting that back and forth from its public IP to whatever is going on in my network. You
got it exactly. Okay. And so that's what's known as a source NAT. So your source IP on a MikroTik by default is going to be a 192.168.88 dot something, right? And we've all probably heard 192.168. So that's your private masqueraded IP. That's your private IP. The masqueraded IP is the public IP. So in my case, 69.84.166.23. That's my public IP. I only get one of those, but I've got dozens or hundreds of devices that need to masquerade as that IP. So that's a source NAT. DestNAT, on the other hand, rewrites the destination IP. So if you think about it from a firewall perspective where the traffic is coming in from the internet and it needs to get to a device on your local network, like a server maybe running your web server, right? So you would say, hey, ports 80 and 443, which are the well-known ports for running a website. Hey, when 443 and 80 come in on this masquerade IP, this public IP, I want to do a translate that translates the destination IP of my 69.84.23.166, right? You're going to change that IP to the public IP of 192.168.88 dot whatever the server is.
Okay. All right. Well, that makes sense. Hopefully it makes sense to all the novices out there. The person that asked that,
explaining to the novices than I did, but I got the technical backup there for how you're getting that stuff to work.
We've got a whole broad scope of people in the community, so or knowledge people that have in the community. My coffee's not kicking in. Excuse me. So, but yeah, we'll see. We'll follow up with that person and see if that did answer their question.
Right on.
And
so looks like we're up on 30 minutes here, so we better wrap up for this time, I think, and leave some questions for next time. But go ahead, George.
No, I was just going to suggest the same thing. I was noticing that we were getting close to that time, and we don't have any other questions in either of our streams. So I think it would be a good time to wrap up. Again, I wanted to thank you for taking the time out of your day to do this. I know you're pretty busy, got a lot of stuff going on, and it seems like you had to clear the office out as well, so now those guys are still standing out in the hallway, right? We'll let them come back in. But thanks again, Mark. Thanks for you that were able to catch this stream, and for those that are watching it on the recorded version. Again, if you guys have any questions or even any topics that you'd like us to cover, please don't hesitate to drop those in the comment area of this video, or shoot us an email at Marc, M-A-R-C, at mcpnetworks.us, and he'll be able to get those. So I probably just flooded your inbox. You're getting flooded.
I hope not, but we'll make it even easier. Marc at aries.net, right?
Marc at aries.net, absolutely.
That one's easy, AEREZ.net, and Marc's with a C, so M-A-R-C.
Marc with a C, yep, funny spelling. All right, well, thanks again, Marc. Thanks again, everyone, for coming out, and we will see you all in 2 weeks.
Thanks.
Yeah, no problem. We'll see everyone in 2 weeks at the next Tech Talk Wednesday.
Awesome.
All right. Take care.
Have a great day, guys.
Bye.